Hello ladies and gentle ladies, welcome back to another stream. Today we're going to be doing something very different to my usual stream. Well, it's actually not that different because it's actually very relevant to what I usually do, but it's quite different. Today, instead of making a Minecraft mod, we're going to be working on a Minecraft modding IDE instead. So, yeah, this is going to be good fun. I will briefly, obviously, go over everything we have so far, and I will, discuss that as we go along, because there's quite a lot to go through, and there's quite a lot I want to get done today as well. So, let's go ahead and, I think, just get started. So, I probably should have started with the ID actually on my screen, shouldn't I? Let's go ahead and run it. So, I have it just open in IntelliJ here. So, if we run the application, hopefully everything will work. I'm just going to get rid of that for now. Let me just quickly go ahead and do something. So that's going to open in the wrong on the wrong monitor. Let me quickly get rid of one of the things I have here. So there we go. And I'm just going to rerun that. So that's cleared. Okay. So this is Railroad, for anyone who has yet to see Railroad. And yeah, for everyone who doesn't know, this is an IDE that is being developed to be specific to Minecraft modding. You can see I just have a bunch of random stuff here. These are not, half of these aren't even mods, so these are just general folders I opened. But let's go into a mod. It doesn't really matter because we don't have that specific stuff set up yet. But, well, actually, we'll go through the other stuff first, and then we'll actually go into the IDE itself. So, obviously, we can just open a project, and that goes into your browser, and that will open it. You can import a project as well. So, I can import from GitHub. This is from a plugin. As well, so obviously I can do that. We can create a new project, which is kind of the more important one, I suppose. Now this, what you're seeing right here, is probably going to be deleted and recreated very shortly, because we need to set up a whole templating system and stuff. So this is kind of very much the work in progress of the IDE at the moment. But yeah, you can do obviously your usual stuff. This is basically the same as just the MC Dev plugin of IntelliJ, right? It's just creating a project. Jump scare stream, no schedule. Well, I did say yesterday I was gonna I was gonna do this wide. You got to pay attention, man. I don't know why these aren't translated anymore. I'm pretty sure I translated these. I must have accidentally removed the translation. I didn't ping in the Discord. Ah, man. I actually do need to work on TurtleBot, huh? So that it can do this for me. Okay, let me do this. Dev stream for Railroad. And do I have the link copied? No, I don't have it on my clipboard. Boom, nice and simple. Okay. Bro, what the fuck happened to Railroad? This was chopped like a week ago. Yeah, I have redone all the themes, so it looks a lot better than it used to, but it still doesn't look great, and I am happy to admit that it doesn't look great. It doesn't look bad, it just doesn't look great. Like, there should definitely be more padding here, right, between these. That's one thing I can immediately notice. The corners on this filter button are completely scuffed and not correctly rounded. There's a bunch of stuff. I could be here all day pointing them out, but I'm not going to do that. We need a designer, is basically what I'm saying. So if you're a designer and you happen to be watching this stream, hit me up, and I will probably get you in straight away. But yes, new project screen, it just does new project stuff. I'm not going to go through that. I'm not confident it even works right now. The more important thing is the open project, or really just opening a project that we have. The one I usually open is soundboard mod, which was something I was working on a while ago. But we can open something bigger. We'll open Industria. It'll just take a moment. We need to have a loading screen here, because, you know, otherwise I don't know that anything's happening right now. Even though I do know it's happening, but it's going to take a minute. I actually don't know what it's doing. It shouldn't take this long. Oh. Okay. That took way longer than I thought it would. I don't know what it was doing. Oh, I know what it's doing. So I have it set up so when you import a project, or when you open a project in the IDE, it tries to determine what the project is. So it would have gone through and figured out what this project is. In fact, it tells you right here. Here you go. So it's discovered or detected 2 facets. So it would have found probably Fabric facet and the Java facet. It should have also found the Gradle facet. Actually, it might not have found the Fabric one. It might have found the Java one and the Gradle one. Either way, it goes and scans through that, so it has to do a bunch of Gradle stuff. That should really happen async, though. We won't do that today, but regardless, as you can see, this all needs, this needs a designer on it ASAP. If you're a designer, hit me up. I'm probably going to say that a lot because we need one. The usual stuff is here, I guess. I don't know what to tell you about most of it. But we can go into an actual class file, of course. So we have to go all the way down here. We'll just open Industria.java. It's a fairly basic file. We got your syntax highlighting. We got your errors, which we're hopefully going to be fixing these errors today. That's, I think, what we're going to do this stream. And yeah, obviously syntax highlighting looks terrible. That's just because it's just using a random color for each of the different things. That was just so I could test it, and I have yet to change it. So, your usual stuff. Anyways, errors is what I was going to do today. Basically, what we need to do. So for anyone, I guess most of you probably don't know how an IDE actually works. Effectively, we need to take this file, and we're basically writing our own programming language here because we need to go ahead and parse it. We need to lex it, we need to parse it, we need to take this AST that we'll get. It won't be an AST, it'll be it has extra data, it's not actually abstract, but regardless, we take that and then we have to apply some semantic analysis to, figure out stuff. effectively rewriting our own programming language. And we have to do that for Java, we're going to have to do that for Groovy, we're going to have to do that for Kotlin, other stuff as well. I don't know what other languages we're going to have in the future. Probably a few. So that's what we're going to be doing today. You think my mic is hitting it? It might be, yes. 1 second. Oh, yes. I have it the wrong way around. That's why. It should be better now, I think. Is that better? That might actually still be hitting the maximum, I'm not sure. But I think that's probably fine. I have my trusty Fanta again. Okay. So yeah. Alright, have a good dinner, Basti. So, what we're going to be doing is working on the IDE today, since that is the most important part. That's what I want to get done. I say done, not like done, because it's going to take a long time, but we need an actual IDE. So, I can't even see where it is, I'm going to be honest. Where is the actual, like, text editor? Oh, here it is. I haven't been working with this one for a while. I've been trying to write my own text editor. That hasn't gone so well, so we're back to this one. So yes, this is the JSON one. We don't want the JSON one. We want the Java one. So this is it. This is the entire code editor. It's 500 lines, so pretty small. And that produces us this. So yeah, we need to basically figure out, first of all, how to fix these errors. Effectively, I know why we have these errors. So if we look all the way up here, by the way, for anyone new to this stream is going to be very complex. Okay, there's going to be a lot going on, and it's going to be quite we're going to be going quite in depth, so I hope you guys are ready. I will try and explain things, but there are some things that might be too complicated. So right now, the way that this works is we're just using the default Java compiler, right? So this is built into Java in javax.tools. And that does most of the work for us. So if I look at where this is used, you see here, request error diagnostics, which just gets us those errors on the sidebar. What I will do actually is I'm going to put the ID. I'm actually not going to put it in the top left because we don't have a way to like hot swap things. So there's not much point to doing that. But here you go. So this is where the errors on the sidebar come from. So all it does is it takes the file as a string. It creates a new diagnostic collector. And then all it does is it uses the compiler to compile it, right? It just calls a compilation task and then returns the diagnostics. That's it. That's all I'm doing right now. Now this is not sustainable. This is terrible. And this is extremely slow, right? And when I say slow, I mean slow. So like if I go how can we do this? I'm not in debug mode, so I can't hot swap this. But if we do long start time, and then we do railroad.logger debug error diagnostics took that many milliseconds. Let's restart that. And this is really slow, right? So you're going to see that straight away. Which is why we're going to have to write our own Java compiler. Which is what IntelliJ does, I believe. At least as far as I'm aware. That's what they do. How do you hot swap? Basically, you build the program. That's it. As long as you're in debug mode, and as long as you've changed something that is, as long as you've changed something that's hot swappable, you just build it and it will hot swap. So here we go. Industria. This probably isn't going to be a good example because this one's going to take a while to open every single time, but also we have to do this. I can expand all though. Oh, that was a terrible idea because I forgot how many files we have. Okay. If we just give this a second. Yeah, so the syntax highlighting is also very slow, but that's because it's reparsing the entire file every single time there's like a single change, rather than it having incremental parsing, which we need to do at some point. But we can't do that without a custom Java compiler, so that's going to take a while. But anyways, if you look at the logs, you can see, I mean, you can see here the error highlighting, just highlighting the errors, right? So just a visual thing takes 189 milliseconds. That's a really long time. That is a really long time. Here, and look at this, right? Error diagnostics took 3,868 milliseconds. That's 3.8 seconds just to calculate the errors in a 71 line file, right? That's not acceptable. That's just, you know, there's no universe in which that is acceptable, right? So what I want is I want this number right here to be shortened down to about, I want it below 100 milliseconds. Ideally, in an ideal world, this should be below 10 milliseconds. That's what I want. I think it's doable, but it's not easy. So, I mean, what might help, because this, you see this has a lot of errors here. And I think that's partially because it doesn't know what things are, right? So it's saying here, cannot find symbol mod initializer. So it doesn't even know that exists. Or it also says, you know, it can't import any of these classes that are even just right next to it, right? So I think the first step, rather than, you know, rewriting the entire compiler from scratch, which we'll do later on, is actually just going to be to add those additional files. Now, I think we do that in this one. So where this is null here, this is the classes. I think this is just an iterable of classes. So if we have a look at that, we can see names of classes to be processed by annotation processing. Null means no class names. Or file manager, a writer for additional output. I'm pretty sure it's going to be the classes one. Actually, never mind. It might just be this one, compilation units. No, I think that's what you actually compile. And then the classes, I'm pretty sure, are the ones that it actually is like using as like a reference, I guess. Now, I'm gonna let you guys know, I'm probably gonna be using Big Man ChatGPT quite a lot today, because the thing with something like the Java compiler, which is what we have here, is that there is very little information about this online. I can Google, right? Wait, let me get my my dev browser, or my stream browser. Here we go. So if I Google how to use Java x.tools.java compiler, I'm not going to find much. We'll find a few things, but it's not going to be much. So Compile code fully in memory isn't really what we want, but it might give us some information. Not really, because we need to reference other files. So you can see compilation unit is that, and then it does the task. This is probably what I used originally, actually. A class that compiles entirely in memory. Possibly something like this. So this looks like it basically is creating their own compiler. Not really a compiler though, so it's just like reading the files. Which could be what we want. But like, once again, these are useful-ish, but they're also kind of not that useful. Class file manager. Once again, this isn't really what we want, right? None of this is what we want. Maybe I could say... I mean, this is just AI, right? So this isn't gonna be what we want. Are we actually using... I mean, we could use Java C, in theory. That's definitely an option, but that might just use the same thing. Does it say, actually? But because it was written in Java, there's a much we simply import and call this. Doesn't need to start an unneeded JVM. Yeah. So basically, the reason you wouldn't want to use Java C is because by doing that, you're starting a new Java process, right? It's a separate Java process. You have to start up an entire JVM just for Java C, which is why you don't really want to be using that, and that's why we're using javax.tools.java compiler so that it does it within the current process. But I mean, as this says, basically, there's going to be side effects resulting from namespace collisions, which is what we already are seeing, right? So we're seeing that, say for example, that the project, right? The project that we have here, let's say that this project was using Java 17. No, let's say it was using Java 23, right? And let's say the IDE is in Java 21. Right? And let's say, for example, that we were using here a feature that's only in Java 23, right? So this feature isn't in Java 21. We would have a problem there because the Java compiler that we're using, this one, or well, not this one, but this one is in Java 21. So it wouldn't be able to compile a Java 23 file, which is kind of a pretty big problem that we have with this. And it's why it's not really viable. I think the best option for us... I mean, I'm going to ask ChatGPT and see what it says. But I think we're going to have to write our own compiler. Well, we will have to, but it's a matter of whether we need to do that today or not. Luckily, writing a Java compiler is pretty simple. At least for the lexing, very simple. Parsing, mid-complexity. Semantic analysis will be the harder part. But yeah. So ChatGPT actually says it's because of the file manager not working, which is interesting. So I'm going to try what ChatGPT says. It could be incorrect. It very much could be incorrect. I don't have much faith in it, but we can try this. So it says that we should probably get a standard Java file manager and set that to be Java compiler dot get standard file manager, which takes in the diagnostics, null and null, which is locale and char set. Okay. And then we check a few things. So trying to look at what this does here. So interesting. I've lost my browser. I need my friggin' stream browser back. Here we go. So this is what ChatGPT is saying. So effectively, this is what it's doing, right? So it's taking the standard file manager, and then it's adding in the path. So it's adding in source roots, class path entries, and module path entries. And then it's also setting just, I guess, an output directory for where it will compile the files to and stuff. And then wrap to expose the current unsafe buffer. I don't know what that does. Disable annotation processing. That is probably something we're fine with doing. Build units. Not sure what that is. Is there an overload for get task that takes in build units? Or just units? Oh, that's compilation units. Right, that makes sense. So what it's saying, anyways, is that we need to do std.set location from paths, and then we do standard location dot source path, and then this uses the source roots. So the source roots that we're looking for is gonna be basically, we scroll up for a second, it's basically gonna be main Java. So it's going to be source main Java, right? So Java is going to be the root. Now, to actually find that is, once again, a little bit complicated because we don't have any kind of analysis of a project. We don't know what a project is. But the best thing, that's probably the best thing for us to do, I'm trying to look to see if the project is accessible in here or not. Because we very much need it to be. Doesn't look like it is, unfortunately. So in that case, we can pass that in. So we can do project, not equals. I didn't mean to do that. And then that will just pass in the project. And then we can have a private final project. Obviously, this should really be in the super, but it's fine for now. And then this dot project like that. And from there, we can go project dot get path dot resolve source main Java. So this is obviously a very hacky solution. And let's turn that into an absolute path. And that throws an IO exception, but that's fine. We can come back to that in a second. Or actually, we can just try catch up. That's fine. IO exception. And then do that. Okay. Then what we want to do is do the class path entries. So actually, let's do this for now. Let's just leave it at this. So we'll go into here, which gives us the file manager. And then let's also pass in another argument to this, which is going to be proc none. Like that. Which I think is basically whether it does annotation processing, which I've set to false. There you go. I think that's what that does. That might not be what that does. Did ChatGPT give you the wisdom from the gods? Yes, it very much did, Wide. Okay, the next thing we need to do is create an iterable of Java file objects which is apparently the compilation units, I guess. So as for exactly how we do that, I don't know. So I'm just going to look at what ChatGPT gives me, and then we'll try and figure out what the actual issue is, or what we actually need to do. So Java file manager is equal a new in-memory. So it uses an in-memory overlay file manager, and that I assume is a class it's created. Yes, it is. But honestly, this is just this is a lot of effort for something that's probably not going to work, right? I'm trying to look at what it has done. Because to get the class path even, right? Because we obviously need the class path. Why will it not work? Well, it will work. It will work. But it won't work to the extent that I need it to work. It's not going to allow for, like, incremental compilation. It's not going to allow for, well, incremental parsing, really. It's not going to allow for that. It's going to have problems when it comes to specific Java versions. It needs to be, like, the IDE needs to be in a higher Java version. There's a bunch of issues that this is going to give us in reality. Because it's just not powerful, and even so, right, even if we could fix all of those issues, look at how long it takes to do it, right? And this isn't going to solve that. This is not going to be a fix for that. You know, even if we're able to resolve all the files, this is actually probably going to end up slower, right? Because every single time the file is changed, this is going to run, which means it's going to basically recompile the entire project, right? So currently it's just recompiling the single file, right? What we had previously, it was just recompiling this file, right? This source code that we've given it. But when we're adding this is now going to recompile the entire project, right? The entire source path. So source main Java, everything under that will be recompiled every single time. And that's not viable, right? So I think rather than wasting time doing this to get something that will kind of work but not really work, I think we should just ditch this and write our own compiler. Now this is where things will get complicated though. And I'm gonna have a few references up that I can look at here. So the biggest reference that is actually going to be very useful for me is going to be my own programming language, since I aimed for something that was pretty similar to Java. Not intentionally, or not intentionally as in to help me now, but not intentionally in general. So we're going to need to do this though. So how do we even get started is, I guess, the biggest question. See, the thing with a programming language is there's a lot of different things. Like there's just many things. I think what we'll do, we're gonna want this in the IDE, I think. And we're gonna go create a new package, and let's call this the what do we actually want to call this? I guess Java compiler. Or you know what? No. Let's do... So, okay, effectively what I want is what IntelliJ has, which is a PSI, which is a program structured interface, I think. Let me have a look though. Yes, right, so this is what IntelliJ has. They call it the program structure interface. Effectively, this is an abstract syntax tree, but it has a bunch of extra information attached to it. Now, once again, ChatGPT is going to be able to help me here, because I created a chat a while ago, and I got it to give me it gave me a thing about PSIs. It was like a whole thing, and I couldn't find it anywhere in this SDK, so I don't know where it got it from, admittedly, but it was exactly what I wanted. I'm probably not going to be able to friggin' find it now. Let me authenticate. Okay. I think this is a perfect use of AI, if I had to be honest, because I'm using it effectively here to do me some research. Things that are hard to Google. So, you know, I'm just going to create a new chat and try and find it that way, because I think I'm going to struggle to find my old one. So, effectively, what I need to ask it is, tell me about IntelliJ's PSI. How does it work? Yeah, so here you go. So it's not just a parse tree, and it's not just an AST. It's a live index semantic model of your code. Blah, blah, blah. So it uses it's an AST, but it has a bunch of other stuff on it, basically. So you got the tree structure. Each file is represented as a PSI tree. So yeah, so each file is its own tree, and that is all inside of a tree. So it's a tree of trees. Yeah, the root is a PSI file, and the children are the PSI element. So the PSI element might be like a PSI method, a PSI class, a PSI field, that kind of thing. And it's generic. That's kind of the point of it, right? So you would have PSI method, which would be the same in Java, Kotlin, C#, whatever, right? The point is that there might be some extensions specific to that language, but they will all extend from this PSI element. And then they plug it via a language or parser definition. And then it has a live view, so it stays in sync with the editor. That's fine, whatever. That's a later on thing. And then those can be cross-referenced by IntelliJ's index system. We'll come back to indexing. That's a whole nother thing. I've already half wrote an indexer, so that's fine. We can come back to that later, and I can kind of integrate the two, so that should be okay. When IntelliJ loads or edits a file, so the file is a virtual file because it could be over disk, jar, network, whatever. For now, I'm not going to have that. It's just going to be a path, but I might maybe want to represent it as something similar. I don't know. We'll see. And then we have a document. I already have that. I already have the document. And then this is the part I was looking for. So you start with the Lexer, of course. So you turn basically the string of text into tokens. And then you pass them, so that consumes the tokens and it produces an AST structure like that, but that's structural only. So then it runs the semantic analysis stage, where it's basically assigned the necessary things to each of the. It is kind of semantic analysis. It's more like a yeah, I don't really know what you would call this state. It's not semantic analysis because it's not. I mean, it is, but it's not. It's not full semantic analysis because that's another stage. But it's basically setting up like, okay, what is the parent of this element? What is what children does this element have? That kind of thing. And then afterwards you have got like indexes and stuff. So really what we need to do right now, like as right now, is write a Lexer. That's what we need to do. So what I was saying is I kind of have this already. But we are going to write it from scratch today. So what do we have here? So this I'm just going to call the... what should we call it, guys? So IntelliJ calls it a PSI. A program structure interface. I've just asked it to give me another name for the PSI so we can call it something. Sure, let's call it the SST, so a semantic syntax tree. I think that's fine. Also, look at this. This is crazy. Wait, this is actually crazy. Look at this. So, all I said, right, was tell me about IntelliJ's PSI. How does it work? Blah, 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 blah. Could you give me a more generic or another name for a PSI? Blah, 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 blah. If you want, I can give you a list of 15 to 20 possible names along with the connotation each one gives, so you can pick one that matches your branding for Railroad IDE. It knows, man. I haven't said anything in this conversation about it being for Railroad. But it knows. It knows it's for Railroad. That's kind of crazy. I did not expect that. I don't think that's a good thing. Yeah, in those some other chats, basically you can in the settings you can enable chat something. I don't know. It basically is able to get context from other chats that you've had with it. That's the first time I've seen it actually do that, though. And that is kind of crazy. But anyways, so let's call it the SST. SST. We'll probably rename it in the future. It doesn't really matter. Let's create a new class in here. We'll create a new package actually. So package, which will be the Lexer. And then we'll do another new package, which will be the parser. And then we're going to want another package. We're going to want something like we're going to want the actual AST. So AST. And then we're going to have the, another package, which will be for semantic analysis as well. And we'll want another one as well for indexes, but we'll come back to those. So we'll start with the Lexer. So let's create a new class. Let's call it a Lexer. Speaking of, I'm going to unplug Alexa because it's already trying to listen to me and it's probably going to try and dox me. So I'm not having it do that. I'm going to ask ChatGPT to give me a generic Lexer. Not like the actual Lexer, but like an interface I can use as the Lexer. So, can you generate the... Oh, I'll show you guys what I'm typing. Because I know how to write Alexa, but I don't know how to generalize Alexa. Because it's yeah. Like if I look at my Alexa that I've written, right? Basically, you obviously have the Alexa. You have your constructor. Mine just takes in a byte array, but you can obviously take in whatever you want. And then I have a lex function, so that just turns whatever the source is into a list of tokens. So it will use next token. So I guess, do I just have a lex function and a next token function? Because everything else is kind of language specific, right? I've got here multichars, I've got slashes, I've got identifiers, strings, multi-line strings, characters, UTF-8 code points, numbers, integers, floating point numbers, I don't know what the difference is, escape sequences. I think I'm going to be better for asking it what it thinks a lecture should be represented as. An interface or abstract class that represents a generic Lexer. No code for the actual Lexer, just an abstract structure that all Lexer implementations will use in Java. I think it's just going to give me an abstract class that has a constructor that takes in a string or a byte array. It's going to have a function that turns that into a list of tokens, and then it's going to have a function for the next token. I think that's all it's going to be. Oh, it's actually got the whole like look ahead and stuff inside of this. So in my language, I separated this. I created a source reader class, which basically does this for me. And that's because I wanted to eventually integrate a ring buffer, which would have much better performance than just like a byte array that's stored in memory, because otherwise you're limited with a byte array. So you can only have like, the max size of an array in characters, which is, not ideal per se for larger code bases, but so what's it actually done here? I feel like it's created some unnecessary things. So it's got the next token, fine. It's got a look ahead, fine. Is it end, fine. Next token is, fine. Next token type, blah 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 blah. That's fine. Unread is a weird one. Push back a single token previously produced by next token. Not sure about that one. Offset, line, column, whatever, that's fine. Total length, whatever, that's fine. State snapshot, I'm not sure what that is. I guess maybe you would want that. Restore. Int mode. Current lexing mode. Useful for languages with string, template, regular expression submodes. Int push mode. Pop mode. Any non-fatal lexing diagnostics. And then a source identity. So, whether that be a path, a URI, or a display name. Close, of course. And then it has the state, and then it has a lex error. It has a token. That's fine, that makes sense. Then it has an abstract class for state snapshot. Interesting. I don't really know why you would want that though. But sure, we'll add all these things. And we can just remove ones that we actually don't want later on. So initially we're just using an enum. So t extends enum of t. And then this whole thing extends closable, because we want you to be able to close it so it frees buffers and stuff. That makes perfect sense. We need a way to get the next token. So I'm just going to call token t next token. That's perfectly fine and normal. Token t look ahead of int n, which will get us, however many ahead. Let's call it k actually, because usually look ahead is just referred to as k. Like you can have like a K1 language or a K2 language. So I think k makes more sense than n. Then we have a default boolean, which is for whether or not it's at the end, which is returning next token type is. I'm just going to rename this method though to is next token type. And then it has token channel dot default and token flag .eof. I don't know what either of those are. Let me have a look. So in channels, it's got default, trivia, directive, and other. So default, I guess, is just like normal tokens, right? So like, for example, maybe, you know, open brace, identifier, number, that kind of thing. Trivia, it says, is like white space, comments, documentation. So like, yeah, white space, comments, Java docs, etc. And then directive, it says, is a preprocessor thing. So like, I don't know much about preprocessors. I know C++ has them. So I guess that kind of thing. And then I don't know what other would be, but I guess it just makes sense to have an other channel. Sure, that's fine, I guess. Sure, that's fine. Then we have a default boolean is next token type of T type, which does a look ahead of one type is equal type. That's fine. So look ahead basically won't consume the token, whereas next token would consume it. That's basically why these are two different methods with two different names. Then we have another next token type is, which does the same thing as this, but also takes in the channel. So actually it doesn't. It does token channel, and then it does token flag, and then basically that. Hello, Agent Cryo. Welcome to the stream. And hello, I don't know how to say your name. Hey. Okay, I genuinely have no idea how I say your name. Hey Bim. Maybe. I might be close. Am I close? Let me know. Default void unread token of T, which is the token, and then that throws an unsupported operation. Then we have the int offset. We have int line, int column, optional of integer, total length. Let's import that. Now, then we have this snapshot shit. I'm just trying to call this a snapshot. So snapshot. Then we have void restore snapshot. We have int mode. We have int set mode. In fact, ChatGPT says we should have a push mode. I guess that means that the mode is like a stack, right? And then we have a void. Well, this actually says an int pop mode, but sure. That's good enough for me. Is this shit from your own Lexer? This is from ChatGPT. Why? We haven't got to the actual Lexer part yet, which will be mine. which will be mine, yes. Then we have Lexer, which is the diagnostics. And then we have a optional of string source ID. And then we have close, which by default doesn't do anything. So let's make that like that, because you might not want to actually close it. Yeah, and then we just have interface. We want the snapshot first of all, so snapshot. Then we have a record Lexer, which is going to take in a string message, int offset, int line, int column. Like that. Okay. Perfect. Then we need the actual token as well. So let's grab a token, which will be an interface. And it says t extends enum of t, which I'm guessing will be the token type. So t type. Then we have the channel. We actually want some other more important things first than the channel though. So we want, for example, the string lexeme, which is basically the data that the token stores is effectively what a lexeme is. It's like a I like to think of a lexeme like a phrase. If it were to be English, it's like a phrase. Well, no, I guess it's not a phrase. It's like I don't know. It's like a word, I guess. Kind of hard to explain. Anyways, we have a line, we have a column, we have the channel, we have the set of token flags, and then we have a default int length, which returns the end offset negative the start offset. And then we have a simple token, which basically just takes these all in, like that. I will copy the constructor that ChatGPT is giving me though, which is this one. So that just sets all of these to be, you know, what it needs to be. Then we have the token channel. So this will be an enum token channel. This will be default. Trivia, or I prefer trivial. Then directive, or let's call this pre-processor, and then other. I don't like trivial, I'm gonna be honest. Let's do no, fine, we'll call it trivial. I'm not sure that's really the right word, but we can add comments. So we can add like a white space, comments, etc. And then we have this, which is preprocessor directives. And then this is just like normal ones, and then this is for other ones. And then we have the token flag, which is also an enum. So we have EOF, we have error, we have incomplete, and we have synthetic. So synthetic is like, yeah, this basically. We'll change these to Java later on, but that's fine for now. So that fixes that. That fixes all of this. This just needs to be imported, of course. And then it also wants us to create an abstract Lexer state. So we can do that. Abstract Lexer state, which is just like basically a default state. We didn't call it a state, but we called it a snapshot. So we can then implement Lexer.snapshot. Then we can have a private final int offset line column and a private final int mode. Create the constructor, and then we need methods for all of these. So toString. Okay. Then we want equals and hash code. Equals hash code. And then we just want getters. Although these can be like that. It's never used. Convert to record class. It could be no, we don't want it to be a record because this will be an abstract class like that. So no, we don't want it to be a record. But that's fine. Okay. Now, the next thing to do is going to be to have implementations. So let's do import, and then inside of there we're going to do a new package for Java. Refactor rename. No, oh my god. Refactor rename. Thank you. And then we'll do a new package again, just to have this not be import.java. So I'll do like the one we'll do after Java will probably be Groovy. So we'll do Groovy. Okay, instead of Java, we're going to want the Java Lexer, which will extend Lexer. It's actually going to implement Lexer, isn't it? There you go. Implements Lexer. And then we're going to need Java token type. Like that. This is going to be an enum. So then this will be like that. These are now all going to complain because they are raw. So let's just implement them again. There we go. Now, I am going to ask ChatGPT to list me the tokens, because Java has a lot of tokens. And when I made my language, I didn't add all of them. So, can you tell me what tokens would be in the Java language? Oh, there is the specification. Actually, it has just said that. So I'm going to look at that first, and then we'll go from there. I've got to actually find it first. Let's go this one. Here we go, chat. You guys ready to read the Java language specification with me? This is for Java 24. This is going to be very exciting. Can we get Dark Reader, please? Let's get Dark Reader so you guys aren't blinded. Here we go. Dark Reader for Chrome. Add to Brave. Add extension. Okay. It's a little bit better. The website is still shit. But here we go. Okay, so. It's not going to be all on this one page, is it? No, because this is just the... This is actually pretty cool. I've never looked at the JSC before. Oh, J... Is it not JSC? JLS. That's it. Yeah, I think you're right, Basti. I think it has... Yeah, it's basically the same site that it's just had this content updated. Anyways. So, this is just the introduction. We don't care about any of that. This just talks about the grammars. That's fine. What we care about is the lexical structure. So, can we... can I turn on reader mode? Here we go. This is much better. And can I make it read for me? Because I'm lazy. Let's do... this one. There we go. Oh. 1 second, that's not what I wanted. Oh, I just wanted to actually hide the view. Can I not do that? I want the audio to be there, but not the window. Ah, whatever. Sure, here you go. So here's the window then. Hello, I'm new here, and what exactly is Railroad? So Railroad is basically an IDE that I am designing, and it is an IDE for Java. So it is built in Java. No, it is built in Java. It's not what I meant. It is built in Java, yes, but it is built for Minecraft mods specifically. Hence, what we're doing today is we're writing our own Java compiler, basically. Should we read this and let's see what it sounds like, by the way?
Chapter 3. Lexical.
Okay, is there not any better voices?
Lexical
We might have to read this in Edge, chat.
structure.
Yes, let's read it in Edge. I hate this. The music has stopped anyways, actually, so we can use Edge. That means we don't have Dark Reader again, though. Does Edge have a... Does anyone know if Edge has a reader mode? So that this is actually, like, readable? Let's get rid of this, by the way. There you go. So what exactly does it mean by being built for Minecraft mod? So effectively, it will just have Minecraft mod specific stuff. It's kind of hard to explain. Ah, I found it. Immersive reader. Reading preferences. Can I? Does it not have dark mode? Text preferences. Aha, found it. Found it. Okay. Here we go. Read aloud.
Chapter 3. Lexical structure.
Oh, one second. I need to set my audio. Because I can't hear it. Because I have my I have Edge not set to be output to my headphones, so that I don't have to hear the Minecraft musical stream. Let's try that.
Structure. This chapter specifies the lexical structure of the Java programming language.
Here we go, lads.
Programs are written in Unicode, section 3.1, but lexical
Okay, let's make it go a little bit faster.
Provided, section 3.2, so that Unicode escapes. Section 3.3 can be used to include any Unicode character using only ASCII.
Okay, we don't care about any of this. 1 second. Let's go ahead to what we actually care about. Which is none of this, none of this, none of this, none of this, none of this. Aha.
The result is a sequence of line terminators and input characters, which are the terminal symbols for the third step in the tokenization process. 3.5 Input elements and tokens. The input characters and line terminators that result from Unicode escape processing, section 3.3, and then input line recognition, section 3.4, are reduced to a sequence of input elements. Input element, sub.
Okay.
Input element.
This might not be very helpful. I thought this would be more helpful than this, but in fact, this is not helpful. Like, what is this, bro? Can I turn this off? How do I undo? Because I think it is... I can't be asked to read all this, man. Look, okay. This says it's going to take half an hour to read this. I'm not reading this whole thing. I'm just going to use what ChatGPT's told me. So here we go. Whitespace and comments. So not significant tokens in the grammar, but Lexer still detect them. IntelliJ puts them in a trivia channel. So we have whitespace, we have line terminators, we have line comments, block comments, and java.comments. Okay. So let's do these first. So we're going to have whitespace. We're going to have line terminator. We're going to have line comment. We're going to have block comment. And we're going to have java.comment. Then we have the keywords. So these are trivia tokens. Then we have the keywords. So we have abstract keyword, assert keyword, boolean keyword, break keyword, byte keyword, case keyword, catch, char, class, const. There's no const, is there? It's actually a thing. Like, it's actually like a reserved keyword. Does that mean I can't say, like, int const is equal 5? You can't. Damn. Const is a reserved keyword, I guess. Kind of weird. But sure. Continue. Default. Do. Double. Else. Enum. Extends. Final. Finally. Float. For. Missing one. Wait, no. Yes, missing one. Go to needs to be there. Then if. Then implements. Import. Instance of. Int. Interface. Long. Native. New. Yeah, null. I don't know why it hasn't added. Oh, I see. I see. So ChatGPT split this into two sections. So ChatGPT's got strict keywords. So abstract is a blah 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 blah. It's got native, new. Then it's got package. Then it's got private, protected, public, return, short, static, strict FP. Still have no idea what strict FP is. Super, switch, synchronized, this, froze, transient. Still don't really know what transient means. Like, I kind of know what it means, but like not that much. Try, void, volatile. I once again still don't really know what volatile means. Here we go. And while. Then we have contextual keywords. So that's like exports. Then we have module keyword. Then we have non-sealed keyword. We have open, opens, permits, provides, record, requires, sealed, two. These I've never used like half of these. Probably like 70, probably like 80% of these I've never used. It's kind of funny. Transitive uses bar with yield. Okay, then we have literals. Literal. So we have null. We have true. We have false. We have integers. We have floating points. We have characters. We have strings. We have text blocks. I think that's all the literals. Then we have identifier. So, yeah, I mean, there's only one, so there's no point having that one. Then we have punctuation tokens. So we have the open parenthesis, close parenthesis, open brace, close brace, open bracket, close bracket, semicolon, comma, dot, ellipsis. And I guess you kind of have colon. You have colon, right? And you also have question mark as well. But I guess we can leave those ones because those are more like, I would consider those to be operator tokens, right? Because they're more like operators. So you have, for example, in operators we have a sign, we have plus, we have minus. Yeah, I'm going to go in the order that ChatGPT has because I don't want to get out of order and then miss one. So we have equals. We have I'm trying to look at the order that it's done this in. It's a really weird order. Oh, no, I see the order it's done it in. So it's done it like this. So it's done a sign. Then it's done greater than. then it's got less than, then it's got not. So it's got like single character ones, right? So then it's got this one. What's this one called, guys? Does anyone remember what this one's called? It's the Boolean one, isn't it? Oh my god, what's it called? It's Java. What's it even? What's even the name of the character called? Squiggly squiggly line character. No, that's not gonna give me what I want. Java, character. I can't find it. Tilde, that's it. It's a bitewise operator. It's bitewise not. Right. So what do I call it? Yes, I see you, Basti. Keep saying it. It's called a bitewise complement operator. They are called bitwise. I know, but I prefer to call them bitewise. Because bitwise just sounds weird. Like bitwise, really? But yes, they are fine. We'll call them bit. I'm so stupid. We'll call them bitwise operators, okay? So what did I just say this was called? I've already forgot. Complement? I think. Then we have the question mark operator. Java question mark operator, which I know is used in ternaries, but I don't know like what is it called? Does it have a name? I'm just gonna call it question mark. I don't know. Ternary question. Ternary colon. There you go. What library do you use for the app itself? We are using JavaFX for most of it. Yes. Or I could just do. But the thing is, the colon isn't just for that, is it? Because the colon is also used in loops. So I'm just going to do question mark. And then colon. And then we have the arrow for lambdas. So arrow. Then we have double colon. Double colon. Then we have equals. You know, I'm gonna do this. I'm gonna do equals. I'm gonna do greater than, less than. I'm just gonna do this so that I can keep track of like what ones we're talking about here. Then we have greater than or equals. Then we have less than or equals. Then we have not equals. Then we have and, which I would just say is and, I guess. I'm actually going to call this a bitwise complement as well. Reason is because we're about to have the other ones, so it just makes sense to do it like that. So we have and, then we have or, which is that, so it should be that way around. How is not equals it? Because it is, because it's not a not a sign, is it? It's a, it's a not equals. Like, they're fundamentally two different things. Then we have plus plus. Then we have minus minus. Then we have plus. Then we have minus. Those should probably go beforehand though, like that. Then we have multiply. Then we have divide. Then we have modulus. Then we have bitwise and, or sorry, bitwise and. So stupid. XOR, left shift, right shift, unsigned right shift. We have plus equals. We have minus equals, multiply equals, divide equals, modulus equals, and equals, or equals, XOR equals, left shift equals, right shift equals, unsigned right shift equals. That's so stupid. Unsigned right shift equals. Has anyone ever used this? Ever? Has anyone ever used this? I wonder in history of. I mean, IntelliJ doesn't even have a what do you call these? Well, when it like combines it into a new character. Either way, IntelliJ doesn't even have one of those for this. So this class is going to be used to read the code. This class is just a list of the tokens that exist. And then yeah, we kind of go forward after that. Yeah. Do we not have... This is a keyword, though. Do we not have that? Yes, we already have that. So why... Okay, whatever. Ligatures, that's it. Thank you, Wide. It doesn't even have a ligature for that. Kind of crazy. I think that's it, though. The last one is end of file. EOF. End of file. And then... Sure, we'll have unknown as well. Oh, it recommends, actually, that instead of having a true and false literal, that we have a Boolean literal. I don't know if that's better or worse. What do you guys think? Oh, also, another one we want as a keyword, and this is a weird keyword, but it is technically a keyword, is the contextual keywords. We want underscore. Because that is technically a keyword. It's a weird one, but it is technically a keyword. And then, yeah, so ChatGPT recommends that true and false are just a single Boolean literal. I guess that makes sense. That's not true. This one's true and false. That makes sense. We can do that. Okay. Perfect. I'm going to move this one next to the other bitwise ones, like that, so that those are all together. Just try and keep things a little bit together. But I mean, it's hard to categorize them all exactly because they're all quite different. But I think that's good enough. So that is 148 minus like 10 or minus, yeah, probably about 15 maybe. So, you know, that's what, 120 something. I can't do math, man. No, 100 and wait, how many was it? Okay, I don't know. There's a lot. Anyways, is the point. I already lost count of how many was in the file in total. Yes, but I'm not gonna do values.size and then friggin' run it and my basti. Like, that's silly. Okay. So we done that. Now we have to actually write the code, which is the easy part. Okay. I don't know how to implement these methods it's given me. I'll be honest. Is it best to just... because the problem is it has all of these things and things. So I'm just looking at what ChatGPT recommends, since it did write the template that we have here. It recommends there is 3 modes. That we have. So it wants us to have a mode. So do this: private static final int, and then this is like default mode. So mode underscore default is equals 0. Then we have then it wants a mode string. So this is like when you have mode, when, you know, when you put something in here, right? So, oh my gosh, I forgot about Lex Manos. Is he still on the portrait? I think so. I think he's still going about. I don't think, yeah, I don't think he's stopped. Text block is equal to, there you go, which would be the triples. Okay, then we have a private final char sequence, which is the input. We have a private final int length. We have a private final string source ID. We have a private int offset, a private int line, and a private int column, which just keeps track of everything that we need to keep track of. We also need to have a stack for the modes, so that we know kind of what we're inside of at the moment. So we can do a private final deque, I guess, of integer, which will be the modes is equal to a new array deque. Like that. And then we want the diagnostics, so private final list of lex error, which will be the diagnostics. Is this your Lexer now? Yes, this is the Lexer. Then we have a private final, once again, another DQ of a token of... Wait, what's this? What's this for? Trying to have a look. Okay, sure. So, is your Alexa super good and it is pretty fast. Yes, it's not like amazing speed, but it's pretty fast. I mean, I'm sure it could be improved, but it's pretty fast. Okay. Anyways, then we're gonna have this. So we put the input. Actually, I think we have the same fan. My fan is just a very generic fan. I don't think it's even branded. Should I have a look? Zanussi. Is your fan called Zanussi, Basti? I'm pretty sure all fans look pretty similar, so we probably don't have the same fan. Okay, let me drink some water instead. Okay. So this is fine. So this just pushes the default mode, sets the offset, sets the line, sets the column. I'm just trying to, yeah, so we don't have the same fan. It was pretty improbable that we would have the same fan. But it's also black and spins and has that point on the back part. All fans do that. Do you have 3 buttons at the bottom? No, I have 4 buttons at the bottom. It has a 0, a 1, a 2, and a 3. Where did you read the name of the fan? The name of the fan is behind. It's like on the top. It's like wait till it turns around. It's there, where my finger is. That's where I read it. Anyways, next token. So we need to look at the look ahead buffer. So if not, this is the look ahead buffer. 1 second. Look ahead buffer. But mine is missing its cover, so I can stick anything in there. It's very fun. Paper. That sounds very dangerous, Basti. For anyone watching, I would not recommend you do such a thing. Okay, so if the look ahead buffer is not empty, then we're going to return look ahead buffer.poll first. Then we need the token. So we're going to say token of a Java type token, or Java token type is equal to produce next. We'll just call it produce next. Sure. If token is equal null, we won't bother with that. We'll just return token, and then I'll just write it to do. do possibly null check. Are you also going to do the parser? Yes, I am going to do the parser as well. That will come afterwards, but we need to do the Lexer first, so that's the plan. So if k is less than or equal to 0, then we want to throw an illegal argument exception saying that the look ahead must be greater than 0. Then what we need to do is say while it is less than k, then we need to do the look ahead buffer, and we need to add to the end produce next, which will produce us the next token. And then we return the look ahead buffer dot stream dot skip to k -1, and then we're going to find the first element and say or else get, and we basically want to supply it with the end of file token. So I'll just have a method, something like a this is a supplier, right? So this create EOF token, something like that should be good enough. Okay, then we need to override unread. No, we don't, because we're not gonna do it like that. We need to do the offset though. So offset line column, nice and simple. Total length will be optional dot of length. Snapshot will return a new abstract Lexer snapshot. Apparently I need toString, but I don't think I do need toString. So this just takes in the offset, the line, column, and mode. Like that. It doesn't like this. Modes.peak may produce null pointer exception. I think that's fine, I guess. I probably want like a special snapshot for this. So we'll call this like a Java Lexer snapshot, which will extend abstract Lexer snapshot and add the constructor. And then I'm just going to take in a few extra things. So I'm going to take in the diagnostics, so list of lex error diagnostics. And I'm also going to take in the stack, so the DQ of that, which is the look ahead buffer. And then these will be private final things. These are public final actually, so we can just make them public as well. So public final list of diagnostics, and then the DQ. Like that. And then we can just override the toString. How can I... Sure, that's good enough. Equals. Return super dot equals. There you go. And then hash code. Sure, that's good enough for me. What we can do actually is return super.hashcode plus objects.hash diagnostics look ahead buffer, like that, which will get us the hash code as well. We don't necessarily need to do this, but I think it just would be a good thing to do, really. So we'll do that. We don't want these Copilot. Why are these complaining? Because it's put them in the wrong order. Thank you. Nice. Okay. Perfect. We need to do restore, of course. So that's a good first thing to do. Check that we've got the right type. Java snapshot.offset. That's not a method, not a method, not a method. Like that. Like that. Like that. Perfect. Then we can do mode, so modes.peak. In that case, we can just do mode there. Push mode, which will do this. And then that returns the previous one as well. Push mode, yeah, this should be... This needs to return an int, which is the previous one. Push mode, int. There we go. I thought I did that. I guess I didn't do that, but... It's fine. So we can do int. And then we can say int previous, which will actually just be mode push return. Perfect. I'm actually just going to do not equal to any of these and then say invalid mode like that. Okay, pop mode, never mind, we need to do that one first. If modes.size is less than or equal to 1, then we say cannot pop the default mode. We need to say less than 1. So it is empty. Yes, that would be that would be correct. Yes. But what I wanted to do, I wanted to say if the modes.size is equal to 1, then I just want to peek it. So I just want to return mode. Then I want to pop it. So I want to do modes.pop. And then I want to peek it again, right? So I just want to return mode. Like that. Diagnostics returns the diagnostics. I don't know if it should be unmodifiable, but I'm going to make it unmodifiable. And then that just returns the source ID. And then we need to create this produce next method. So we need to go private token. You know, fine, we can do EOF first. Token does not exist because we don't have a way to create a token yet. Let's look at actually what ChatGPT says for this one. Oh, we do. Right. We need to simple token. I forgot we even had that. But yes, we have that. Expected 8 arguments, but found 5. Let's look at what it does for this one. So EOF, then it has the... Oh, then it has the lexeme, which is nothing, right? So that's just empty. Then it has the start offset, and then the end offset, which are both going to be exactly the same, of course. Then the line, then the column. Then it has the channel, so that will be the token channel dot default. And then we have the flag as well. So we can do an enum set dot of token flag dot uf, like that. Hello fun, welcome to the stream. Okay. So next, we can create our function, finally. Our produce next function. So we can do, we're going to have this at the bottom. This can actually be, never mind, it can't be static. Either way, we can have a private token of a Java token type, which will be produce next. Okay, first of all, if the offset is greater than the length, right? So if we're past the end of the file, we just return our EOF token. So we need to, if offset is greater than or equal to length, return create EOF token. Nice and simple. Then what we want to do is look for the like white spaces and stuff. Let me 1 second try and find exactly what I did for this one. So all I did for white spaces is I got the character and I just did if character.is white space, which works most of the time. And that would be fine, but that won't necessarily give us comments. So we need to do comments as well. So there's many ways to do this, to be honest. And I need to account for Java docs. That's the big thing. Because I didn't do that in my original, but I think this is fine. So I'm going to get what I have up on another monitor. I'm going to split this monitor. There we go. And then I can kind of see okay, so we're going to want a couple methods to help us here. First of all, because we need a way to be able to actually get the current character, we need to be able to peek the next character, and we need to be able to see if it matches a character, like without moving forward, right? So let's create some methods to do this. I'm going to put it before this though. So I'm going to go private. Let me look at my methods so I can see. I'm going to turn Copilot off from now on because it's getting confusing. It's starting to get in my way. So, first of all, we need to get the current char, right? So, we'll just use char at, basically. Oh, no, this gives it at a specific position, right? So, int pos, which will return this dot input dot char at pos. Pretty simple. Then we need a peek function. So we need a private char peek int offsets. Then we go int pos is equal offsets plus we need this dot offset plus offset. This dot offset should really be the position in reality. There we go. So that gets us the position. Then we need to return, and we need to see like if it's in the range. If it's in the range, we need to give it a null byte. If it's not, then we need to return obviously whatever's there. So we have pos is greater than or equal to 0, so that it's greater than the start, and pos is less than this dot length, and if it is, then we need to get the input, so char at pos, or a null byte. So for a null byte, that's just \0. I'm back. The electricity is gone. That is rip, man. I hate power cuts. Power cuts are actually. I mean, I haven't got a power cut in a very long time. But when we do get them, they are very annoying. Because, like, you know, things only last so long without power. And then, you know, you got a problem at that point. Anyways, let's match. And match is going to be pretty simple, so we'll just return offset is less than, no, I didn't call it offset anymore. This dot parse is less than length, then it's going to be char at pos is equal to expected. Like that. Oh, wait, have I, no, this is not meant to be that. This is meant to be that. I'm getting lost in my own code here. Then we want a way to consume. So obviously consume will just move to the next character. So private void consume. Okay. And then we get the char, so char c is equal to char at, and we're going to get the this.pos plus plus, which will increment that. Then we need to know if we're going to go to a new line after this. So if c is equal new line, then we're going to do we need to say that we're at a new line. So we're probably going to need this later, if we're being honest. So I'm going to do a private void. I'll just call it new line, I guess. And what that will do is that we'll do line plus plus, right? So it increments the line, and then it just says column is equal 1. And then all I need to do here is just call new line. And then we need to handle \r as well. So if c is equal \r, then we just want to increment the column. And then, oh, this is actually going to be an else if that, and then else, wait, no, never mind, we don't even need this, because this will just do column plus plus, like that. Simple. Then we want to be able to consume by a certain amount as well. So let's do a private void consume int. What did I do for this one? I called it offset. I want to do int k. K, no, we'll go n. And just makes more sense because this is going to be a for I loop. I is less than n, and then we consume. Okay, we got our new line, and I think that's basically everything we want. I'm going to create a token method though. Now, ChatGPT has done this slightly differently to how I would have done it, but I do actually prefer the way that it's done it. So I'm going to copy this from the big man. This needs to be the token.simple token, like that. This needs to be pause, 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 and the rest are all the same. That just saves us having to write those two boilerplate methods. It actually has two other ones as well, which I am going to nick as well. Which is just for error tokens and also unterminated tokens as well. So that's just pause, 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 and that's it. There we go. Okay, so that's all of those methods. So now that we have done that, we can do the next thing. So we need to see if there's a whitespace character. So let's get the current character. So char current is equal to we want to consume. I would like consume to return the char, actually. Return C. And then char char C. C is equal that. Let's just do this. If n is less than or equal to 0, throw a new illegal argument exception. Copilot can write this error message for me. Sure, yeah, that's good enough. Whatever. Thank you, Copilot, to the rescue. Let's just set this by default to \0. So that's a null byte. Okay, perfect. Then what we can do is we have consumed it. Then we can say if character.is whitespace. Then what we're going to do is we're going to is whitespace current. Then we need a way to handle that, right? So it kind of depends on the whitespace that it's actually finding. So what I'm going to do is I'm going to do private we probably shouldn't just consume straight away, actually. That's probably an oversight in my original one, but we probably don't want to just straight up consume, right? We just want to do char at pause. And then we consume once we figured out like what it is. So I'm going to create a read whitespace. Private void read whitespace, and then we go a char current. Okay. So if it's a whitespace, then we're just going to do read whitespace current. Boom. And continue. 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 We don't continue, never mind. We just return. because that returns it. So this returns a token of Java token type, like that. Okay. So, we need to figure out what it is, right? So, we have to match certain things in order to do this. So let's start by saying if it's just a normal like white space, right? So good night, Basti. Sleep well. So we need to say if the current is just a space, or current is equal to \t, or current is equal to \f, then we want to consume and return, right? So we want to consume like that, and then at the end we just want to return token Java token type dot whitespace, the start offset, which is going to be just we need the starting pos, because we're going to modify the pos by consuming and stuff, right? So int start offset is equal pos 13 when should I go to sleep? I mean, it depends how old of a teen you are, right? If you're 19, then you can go sleep whenever you want. If you're 13, then you should probably not go to sleep whenever you want. I guess it also depends if you have school or not, right? I mean, it's very conditional when you should go to sleep. But I'm also probably not one to tell you when to go to sleep, because I'm terrible at having a consistent sleep schedule and going to sleep at a good time. I was, staying up till like 3 a.m. when I was like 11, so I don't think I'm the right person to tell you that. So anyways, we have token, which first of all needs the start offset, the start line, so start offset, start line, start column, and then it takes in the channel, so token channel dot trivial, which I'm going to rename to trivia. Okay. Then we need to see if we match a \r. So else if current is equal to \r, then what we need to do is we need to consume. Then we need to see if we can match a \n. And if we do, then we need to consume. And then we need to say that we've met a new line as well. Nice and simple there. Okay. I think that's it, actually. That's actually all we have. Else, what do we want to do in an else statement? What does Copilot recommend we do in an else statement? Oh, actually, now that I think about this, we want to do this, we want to do this while, right? We want a while loop. We want to do this while the pause is less than length and character is a white space. Then we want to do this. And then else, we just want to break. like that. And then I'm actually gonna get rid of this. Do we want to get rid of this? I think we want to return null, right? Instead of doing it like this, we should really just read the white space no matter what, I think. So I think we should do something like token of a Java token type, trivia, is equal read white space, right? And then say char current is equal char at. Let's get rid of this. And we'll just say while the pos is less than the length. Else we break. And then we also create a boolean, right? Which will be like a flag for whether it's actually found white space or not. So boolean found white space. And then we can say, let's do this. And then we can say found white space is equal true. And then we can say here, found white space is equal true. We can say then here, if not found white space, return null. Else it returns the token. And this could probably be inlined like that. So if it has not found white space, then it's null. Else we return the trivia token. And that way, that in here, we can then just say, if trivia is not equal null, yep, like that, basically, then we just return trivia. So that means that all white space has now been handled, right? Then let's check the offset. So if pos is greater than or equal to length, create EOF token. Then we need to get the mode. So we need to say int mode is equal mode. Then return switch on the mode. And we're going to say case default. We're going to read default, read string, read text block, and default we're just going to return an error token. What's going on right now? Right now we are writing a Lexer for Java. It's very exciting and quite complicated. But yeah, so okay, read default is basically going to be the big chunk of what we have here. So let's come after read white space and let's create a private token of a Java token type, read default. Let's not have all of these that it's created. We are going to want these. We are going to want all of these, so those are all fine. But everything else, we'll figure that out when we get to it. Which is why we probably don't want Copilot enabled right this second. Okay, the next thing we can do is figure out if we have an identifier or not, right? I think that's probably what we want to do. Or, well, we have a couple options, really. We can either do that, or we could do comments. We could do tokens. we could do we can't do strings and stuff because those will be like those will be in these two. I think the best thing we could do right now is comments. And that's what I did in my Lexer as well. The first thing I checked for was comments. So what we can do is we can say if current is equal to a slash, then what we want to do let's do that, but then let's also do and no. No, we're not going to do quite like that. We're going to create another method. We'll create a private token of Java token type, which will be read comment. We're going to want basically the exact same thing as what we had in here. So we're going to do this. Okay. Then what we're going to do is we're going to look to see if we have a comment. So we don't want these because we already have that. Wait, never mind. I accidentally copied those into the wrong place, didn't I? I had to put them in here. There we go. So this will just be found comment. So it's going to be very similar, but not quite the same. So what we'll do is we'll check if current is equal a / and peak1 is equal a /, right? So this means we are looking for whatever, something like that, right? So basically we're looking for a comment, right? A single line comment. Then what we want to do is continue until we found a new line, right? So what we're going to say is first of all going to say found comment is equal to true. Then we are going to consume 2 because we want to consume both of these characters. Then we're going to say while pos is less than the length and the char at pos is not equal to \n, and the char at pos is not equal to \r, then we are going to consume like that. Basically, we continue until we hit one of those new line characters. Now, the problem is that if we do hit one of those new line characters, then we need to figure out what we do with it. And really, that means we need to read a white space. So, what we can do is let's do this, actually. So let's just have that loop inside of there. And we will say if this, right? Then we are going to how are we going to do this, actually? Interesting. Actually, this is going to be a little bit more complicated than anticipated, because we can't just call read white space because that has a start offset. So, although, admittedly, this returns white space like that. So we actually want to return comments anyways, right? So what we can do yes. So what we can do is just return, or we can break. So if we're just gonna break, then we can do this, right? Wait. Oh, because these are not equals, right? So whilst the pos is less than the length, and it's not equal \n, and it's not equal \r, then it consumes. If it equals one of those things, then what it needs to do is exit this. Yeah, so this is I'm a little bit lost, guys. So if we hit a \n or a \r, what we want to do is we want to exit this loop, right? Because at that point we just want to read, we just want to say that we found the comment, we don't care. So I think the best way to do that is say comment loop like this, and then say if this, then what we're going to do is we're going to break comment loop, which will take us out of there, and it will prevent this consume from happening, which is what we want. So if it's equal to that, or it's equal to that, then we break the loop. Else, we consume, right? So this has found that. And then what we can say is return. What the hell is comment loop while? Since when can you... That is called a label. And it means that I can break out of this loop whilst being nested inside of this loop. That's basically what that does. We actually don't want to do that though, do we? Now that I think about it. What we want to do is just return a comment token. Right, so we want to return token. Let's see if Copilot can do this one for me as well. That'll save me a little bit of time. So line comment token channel dot default. So that has the start offset, the start line, and the start column. Perfect. Okay. So that's the line comment. What does this do, by the way? Oh, I see. So it uses the current pos to automatically determine where the end of the token is. That's fine. That makes sense. So that will just return that straight out of here. That's fine. Okay. Yeah, so if it finds these, then it's found comments. While reaches a new line, then it returns the line comment. because that means we're at the end of like this line right here. But if we're still finding characters that aren't a new line or a carriage return, like WE space ARE blah blah blah, then we just go ahead and ignore those. Perfect. So that's fine. I don't think we need this found comments actually. Instead, we need to say else if current is equal / again, and peak of 1 is equal to a asterisk. Asterisk. And if it is, then we want to say boolean is javadoc will be peak 2 is equal to asterisk, right? Because javadocs are /*, compared to normal block comments, which are /*, right? So this is a block comment, and then this is a javadoc. What the hell? No, not that. That's not a javadoc. 1, 2, like that. That's a javadoc. And then this is a block comment. And then this is a line comment. Okay, so boolean is javadoc, like that. Then we want to consume 2, so we just want to consume them. And then say while pos is less than length. We're going to get the char. So char, next char is equal char at pos. If next char is equal star, and peak of 1 is equal to /, then what we want to do is consume twice, and then also return that. So we want to return, if it's javadoc, then it's javadoc comment, or it's a block comment, start offset, start line, start column in the default channel. Else, if we reach a \n, this is actually slightly incorrect. So if we reach a \n, what we want to do is we just want to call our new line function. And then else if the next char is equal \r, then what we want to do is we want to see yeah, so then we want to do and peak 1 is equal \n, then we consume 2, new line, else we just consume. And then we can do unterm. No, that's not correct. Is that correct? Yes. And then here, right, so if we exit this while loop, meaning we've reached the end, basically, then we return an unterminated. So we're basically saying at that point, it means that this yeah, so that means this block comment or javadoc has not been terminated. We've never found this ending */, so it's never ending, right? What are you doing now, lad? Right now, Wide, I am still working on the Lexer. We're going to be working on this for a very long time, because we're quite far from being done. We still got things like lambdas and stuff, which are going to be a little bit complex to do. Well, actually, lexing lambdas won't be too tricky. It's parsing lambdas will be possibly a pain in the butt. Actually, probably not. I guess it's just a yeah, I guess lambdas are actually very simple. It's just a thing followed by a thing. It's the arrow followed by either a block or an expression, right? Well, actually, no, just an expression, because an expression can be a block, right? Anyways, regardless, read default. So, what we want to do in read default is see if current is equal slash, then what we want to do is we want to try and read the comment, right? So if pos is less than length, while pos is less than length, yes, we want to say that this has been unterminated as well, because we're saying there's no \n at the end of it. That's fine. So if it equals a slash, then we want to know what the next character will be, right? So that we know whether to read a comment or not. What are you doing? No, let's not do that, please. Thank you. Let's just stop. I will stop you right there, sir. So we're looking for slash or a star. And then that's fine. We can read a comment. If it's not, then we just want to return a division token, or whatever it will be. So what we can do is we can say if peak of 1 is equal to equals, then we can return divide equals. So divide equals like that. Else we can just consume and return divide. So that's our division, which is fine. That's nice and simple. Now I've got to look at what I do next. So next we have multi-char tokens. So that would be like plus plus, plus equals, those kind of things. I need to go. I'm out of battery and data. Power is still off. Alright, see you later. Oh, I haven't drunk my Fanta. It's probably warm now. It's okay, actually. I expected it to be very warm and flat, but it's actually okay. I swear you're just copying your Lexer. Why will this take long? I'm not really copying mine. The problem with my Lexer is it isn't lexing Java. Even though my programming language is similar to Java, it's not similar enough. It's not similar enough that I can just copy it, because that's not going to work. Also, I don't know why Railroad was still running. My poor CPU, man. But yeah, it's just not similar enough to work. And also, it has some problems, right? And more importantly, it wasn't built for this, right? It wasn't built. This is meant to be produced next, but it wasn't built to be able to have modes. It wasn't built to have diagnostics, and I didn't have any form of look ahead buffer. I had no way of determining like what the source was, so like whether it was from a file, whether it was from a URL, etc. All of which will be essential for an IDE, right? This, I don't want those brackets there. So it would have worked, as in like it would have sufficed for like basic stuff, but when you go something beyond that, it just wouldn't have worked. I mean, the parser probably will be very similar, at least for the most part. Oh, pardon me. But we'll read the BNF after this. I don't know if Java uses eBNF or if it uses BNF, or I don't know. I don't actually know exactly what it uses. Actually, I'm going to have a look. Grammar notation. Here we go. Oh, they actually maybe don't use any of them? The syntactic grammar. Lexical grammar, no. I don't think it actually... They must have like a B in it. No. Huh. We'll cross that bridge when we get to it. I'm sure like Gemini or something will be able to... I'll run in deep research and try and get it to find me Java 24 eBNF or something. And I'll use that. But anyways, once again, distracted. Let's go into here. I'm going to create a... This needs to not be there. It needs to be at the very end. So we want a private static final, and this will be a map. And this is going to be of multi-char tokens. So think of like these ones, right? So an unshined right shift, or a right shift, or a left shift, or a plus plus, or that kind of thing. So what we need is we need a map of Java token type. Actually, no, we want it the other way around. We want a map of string or a char sequence, really. It doesn't really matter, but we'll go char sequence. And we want a map of char sequence to a Java token type, like that, which is going to be the multi-char tokens. Okay. And yeah, so I thought this might happen. So we can't unfortunately use map.of, but we can use a new hash map. And then we can do this. And then we can put them in like that. So that will work. So we've got arrow, double colon, equals, greater than equals, less than equals, not equals, and, or, plus, plus, minus, minus, plus equals, minus equals, multiply equals, divide equals, modulus equals, and equals, or equals, XOR equals, left shift equals, right shift equals, unsigned right shift equals. Okay, that sounds correct. I think that's all of them. Then we do want the same thing for single char tokens as well. So let's do private static final map map of character, which will be these ones, and then we want keywords as well. So for the keywords, I think I can probably simplify this one, luckily. So what I'm going to do is I'm going to do values, for value in values, if value.name ends with keyword, then we replace the keyword, turn it to lowercase, locale.root, so it doesn't change depending on your operating system, because that would be suboptimal. And then it puts it like that. Now, the only one that's not going to work for is non-sealed. So I need to do if value equals non-sealed, put non-sealed and continue. But else that will be fine. That will be fine. So that will be the keywords, and then I can just have a I can have a lookup. So we can go from string blah 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 blah. No, so this isn't quite what I want. So this will be the string lexime. Now, first we look for the multi-char tokens, because you don't want to look for a single one first, because then if you have like a greater than followed by an equals, it's not going to turn into a greater than or equals. It will instead just be a greater than and an equals. So we need to do multi-char first. Now, what we can't do, and in fact this actually isn't going to work because we don't know the length of it. Because some of these are free chars, like these ones, or like this one is 4 chars. So, is this actually a thing? Wait, I'm going to check if that's a thing. If 5 right shift equals 4. Oh, is that not how it works? Java unsigned right shift equals. Operator. It might not even be a thing. ChatGPT might just be lying to me. Shift the base of the number to the yeah, that's not going to be a thing. Oh, that wouldn't be how it works anyways. I'm an idiot. It would be like boolean b is equal 5, and then b right shift unsigned right shift equals 4. Wait, no. Like it would be like 5. It would be like false. No. Wait. How does this work? Maybe it's not a thing. Yeah, I mean that's saying it's only finding the right shift, the unsigned right shift. It's not even finding this equals, is it? So actually, I don't think that's even a thing. I think ChatGPT has just straight up lied to me. But this is definitely a thing. That makes sense why IntelliJ didn't have it as a thing, doesn't it? Because it wasn't a thing. Anyways. So, yeah, what we can do is we need a method that can read the multi-char. But that's not simple because we need to find the longest match, right? Which isn't super easy to do. So I luckily have kind of already written this. So that's going to save us some time. So I have a private optional of a Java token type, which will be a read multi-char token. Okay, and that takes in the char current. Then what it does is it creates this. So this is going to be the Java token type. And then I'm going to say, I'm going to create a method to get this. So I'm going to create a public static from char sequence. Okay. Sure, if it's a single one, then it does this, else it just does this. Sure, that's fine, I guess. So that wouldn't do from char sequence current. Alright, but current isn't a char. Wait, multi-char tokens takes in a char? 1 second. I need to look at my code again. I must have missed something. Oh. Oh, it's not that simple. Okay. Multi-char tokens isn't that simple. So, multi-char tokens is a map of a character to a list of a map.entry of a string to a char sequence to a Java token type. So I wonder if Copilot can figure this one out. Yeah, that's fine. Byte words or is that a thing? No, this one. No, that's not a thing. I mean, that wouldn't make sense to be a thing. Okay, so the last one is or on here. But that's not correct, is it? This isn't all of them, is it? Wait, this isn't right either, though. This has gotten... Yeah, this is incorrect. Let's try this again. So equals would be... Okay, so for example, the first one I had was this. Plus equals is a thing, right? Plus equals. So then it's minus, then it's star, then it's divide, then it's $sign, then it's and, then it's or, then it's that, then it's that. That's not a thing. That's not a thing, right? What? That is not a thing. No, that is okay. Oh my god, AI is trying to gaslight me today, man. What the hell? And then equals arrow. Why is double colon there? What? Then we have not equals, then we have colon, which maps to double colon. You don't have 2 question marks in Java. That's a lie. Is that all of them? Have I done ampersand? Yes, I have done ampersand. Have I done... I think that's all of them. Have I done right shift equals? No. I have not. Right shift equals, there you go, and I haven't done left shift equals either. But that is not a thing. Why does it think that's a thing? That's so weird. Okay, I want left shift equal. Thank you. That's fine, that's fine, that's fine. Just gonna double check it hasn't tried to screw me over somewhere else. That should be fine. So then this is a very different method then. So yeah, in fact that just doesn't exist anymore. And then I would be better off making this public. Not pubic. Public. Okay, there we go. There we go. Boom. Okay, so that's the multi-char tokens. And then we convert that to a list. It doesn't like that because this is a char sequence. Okay. Then, what we can do. I've now got to find that because I've now lost it. Okay, then I think I can just copy the rest. So, we can go Java token type, match type is equal null. Do that, let's do char sequence. Char sequence. Char sequence. This will read it has next. So this needs to be... What does has next do? I forgot. Has next. Okay. Okay, so that's just checking basically if that's saying if pos plus that is less than length, basically. Then we're saying if peak I is not equal to that, then we're saying consume that, and then we're returning an optional of match type. But that part doesn't look correct. Let me have a look. So that returns the token. Yeah, so that needs to return the token. That's the point. It needs to return an optional of the token, like that. Okay, so then pos negative longest match dot length, the line and the column. The line and the column aren't going to be correct though, so we need to go int pos equal this dot pos. No, it needs to be start offset line column. like that. And then this can be start offset line column. Perfect. Hi, why is the left shift inserted 2 times in the list map? It is left shift. It is not. Is it? No, it isn't. You have... Oh, wait. Yes. It's not. This is the left shift. Then... Oh. There's left shift equals. I see. Yeah, I missed that. I'm glad... Well, it doesn't really matter. But, would that matter? Huh. I don't know what that would do. But thank you for pointing that out. There's no unsigned left shift, right? That's not a thing. So, holy moly. But I tell you what, these friggin' helicopters right now going crazy outside my house. Like, it's so loud. I don't know if you can hear it or not. Probably not. I'm gonna guess. But it's very, very loud. I can hear it with headphones on. Oh, you know what we don't have, guys? Come on, why did no one tell me? Music, music, we need music. I can't believe you guys didn't let me know. This is all your fault. Okay, this is really loud. I need to... Oh my god, it's so loud. I can't even hear myself speaking. Okay. I managed to transfer it to one of my monitors. So I don't have to hear it now. That came through so loud on my headphone. I realized because I need music. And I don't have any music on. Which meant that you guys probably also didn't have any music on. I just need to make sure that it's not going to come through on OBS. Yeah, that's fine. Okay. Okay, now I got my music on and you guys have music as well. There we go. What was I doing? I'm lost now. What's the error here? Oh, here. Alright, that's fine. We're not done with that yet. What we were doing is this. Okay. This should all be fine. Yeah, okay. So. What we need to do is in... Yeah, that doesn't need to be there, by the way. Yeah, because that's at the end of there, so that happens anyways. That's fine. Okay. What I wanted to do was I need to say if Java token type dot multi-char tokens dot contains key current. Then what we need to do is read multi-char token. If it's present, return it. Nice and simple. Then we need to say if Java token type dot single char tokens dot contains key, current, then what we need to do, yeah, we want to consume. We actually want to consume here as well, don't we? I think. I think so. I'm not confident in this one, actually. Because in my code that I had originally, I consumed in where is it? I consumed here. So I think this would be different. So like it'll get the current. If I look at pause, then it does pause plus that. But that's doing -1. I think it needs to not be -1. What? Oh, I see. So that does that. So I think this needs to be pause +1? I think. To confirm pause +1 is correct. Because I'm not sure. I'm not sure about that one. We'll have to check that afterwards. So, read multi-char token. Let's go back to here. So, if if it contains single char, consume it, return it. Nice and simple. Nothing complicated with that one. Now next I would normally do strings, but we're not doing strings like that. So the next thing we can do can be identifiers in that case. So, is that a thing? Oh, look at that. That's nice. That saves me a little bit of time. How does this... I'm curious what this method actually does. Oh, it's actually something inside of, like, the character class. Interesting. So, what does this do? Identify is equal string new string builder. Identify append consume, which is the first character. And then while the pause is less than the length, and it's an identifier at the pause, then we consume it. We don't need to really do this, though. Oh, I see, because that needs to see if it's a keyword or not. Well, there is an easier way to do this, though. So we can just consume here. Like that. We can consume here. Like that. Right? That can probably be a do while, can't it? Yeah, I thought so. So that can be a do while. Sure, that's fine. Then basically we can get the lexeme. So we can say lexeme is equal slice, like that. And then we can get the type by doing the keywords. So we can say keywords.get or default the lexeme. So that either gets the lexeme as the keyword as a token type, or it's just an identifier token, and then we return that down as a token by using the type start line, start column. Perfect. Okay, so that's identifiers. Then we have big man digits. Now, big man digits are a pain in the butt. But we can try this. So, if character.is digits. Now, Copilot not Copilot. ChatGPT recommended I use something different though, which I'm curious why. What did I do in my code? I used also character.is digits. So what is ChatGPT trying to do? Like, it does the same thing, it just makes a method to do it. That's so stupid. Okay, whatever. This isn't gonna work. I can already tell you from a mile away that's incorrect. Because numbers are very complicated. Because you have octals, you have hex, you have binary, bunch of stuff. So it's not that simple. You also have doubles as well. So yeah, we need to do all of those. So if it's a digit, then what I'm gonna do is I'm gonna say return read number, like that. Okay. Then we're gonna create this method. So private. I kind of want my structure. View tool windows. Structure? Structure. Because this file's getting a little bit big. So it's just nice to have when it's a little bit bigger so I don't get completely and utterly lost. So, read number. Which needs to take in the current, so chart current. It doesn't need to, actually, because it actually really doesn't need to. Yeah, there's no need for that. Because we can just consume it in the method, rather than trying to do that. So, if we go to read default... Yeah, that's fine. So, chart current is equal consume, which will consume us that first character. Now I can look at my method. So, what I do in here is I do Java token type. Type is equal Java token type dot integer literal. So, by default, I'm assuming that the number we found is just an integer, right? Plain and simple. That's just the easiest, simple one to go with at the start. Then we can say... We need to build the number here. So we need to say var number is equal to a new string builder. Okay. Then we need to check what the current chart is. So if the current chart is a 0, then it gets more complicated, because then we need to know what the next char is, right? So if the next char, for example, is an X, then we know it's hexadecimal. If the next char is a B, then we know it's binary. If the next char is 0, 1, 2, 3, 4, 5, 6, or 7, then it could be octal. Could be octal. If the next chart is a dot, then we know it's a floating point number. So we have to be able to handle every single one of those. So what we can do is say if current is equal 0 and yeah, so and pos, what is it, pos plus 1 is less than length. Okay, then we can do number dot append current. Okay, and then current is going to be equal to peak. So we just want to peak 1. Then we're going to say that the type is equal to a switch. We're going to switch on the character dot to lowercase, because obviously they could be uppercase, they could be, you know, whatever. So we need to switch on the character, which will be current. I'm pretty sure that's correct, right? If I say int my number equals 0x, yeah, you can do that. And you can also do, you actually can't do that though. Oh no, that's because you can't do that. It needs to be like this, right? That's binary. And then octal would be like how do you do it? It would be like a, how do octal numbers work? I don't remember how octal numbers work, chat. Let's Google it. Java octal numbers. So 0757 would be an octal number. Yeah. So that, okay, I see. So yeah. So basically like anything like this. No, not 98, because it has to be numbers between 0 and 7. So like, for example, like that would be an octal number. And in decimal, that's 1035. So yeah, octals are a pain in the butt. So we actually can't make this lowercase, which is kind of annoying, but we can make it work. So type is equal switch on that. Case X and X. Then we're going to be Java token type. We actually don't have hexadecimals. So actually, that's fine. We don't care about that, right? Yeah, that's... In that case, it's just type. These need to be those. Case B would also be the same. Case 0, 1, 2, 3, 4, 5, 6, 7, is going to be the same, so that's also a type because you can't have decimal octals. And then we have double, so case dot, then we know it's going to be Java token type dot floating point literals. So we've got integer, floating, and then the other ones are not relevant. So in reality, we actually only want this one. But we do need to know these ones so that we know if it's valid or not. So we're actually not going to use the type here. Or should we? See, we could store whether or not, like, what the actual type is. So instead of having just integer literal, right, we have something like number int literal, right? We have number hexadecimal literal. We have number binary literal. And then number floating point literal. We could do that. Oh, and octal as well. So number octal literal. By the way, I have no idea why you would ever use an octal. Why would you ever do that? It's a very weird thing to do. But anyways, that means that then this could be a floating point literal. This could be a octal literal. This could then be a Java token type dot binary literal. And then this could be Java token type dot hexadecimal literal. Like that. And then the default case is just type. So that gives us our type by doing that. And then wait, let me just confirm. Int a is equal 0b b. Oh, you can do that. Okay, so I can convert it to lowercase. Character dot to lowercase current. So that means I can just do that. There we go. Okay. Nice. Okay, so that gets us the type that we're now looking at. So we now know that we're looking at one of these types. However, there are obviously some conditions. So binaries need to always be ones and zeros. Hexadecimals can only have 0, 1, 2, 3, 4, 5, 6, 7, 8, A, B, C, D, E, F. And then octals can only have 0, 1, 2, 3, 4, 5, 6, 7. So we have to do some calculations now. Or we have to, we have to confirm something. So, for example, we have to say if type is we have to know if it's not a decimal one. So if it's not equal to Java token type dot floating point, because floating points are a little more complicated. We'll come back to those in a second. Then we're going to say that current is equal consume, and then we're going to append it. So we'll do number dot append current. We might not have these appends afterwards. We might remove them, but I'm just kind of copying what I had previously. So so then we have integer literal loop, which will be the loop that confirms that it's still an integer, right? Because, for example, this one could change to a floating point, you know, at the very end, right? It could be like, like this, and then at the very end of the number, it could go to like 0.4 or something like that. So we have to confirm that it is still going to be an integer number. So while pos +1 is less than length, then we want to set the current char to be peak of 1. Then we need to see if the character is a terminating character. So the way I did that in here, so if current or if character is whitespace current, or 30, have you had a nice day? My day has been it's been okay, I guess. I had my universal credit appointment this morning, which was fun as always. I'm joking, by the way, for anyone who doesn't know. And then I had my driving lesson, and then I got back, and I have not done anything since I got back home. So I haven't really done anything today other than everything I've had to do. So that's fun. What did you do in your driving lesson today? What did I do today? I don't know. Oh yes, I just did lots of like parking up on the left, and on the right as well. Because I had a mock test last week. And I didn't fail on parking up on the left or the right. But I almost did, because I almost hit the curb. So, and also I missed a lot of potential opportunities. Terminate number. We can do. I don't know why this isn't int, but it's a char, so. But yeah, so that's just what I did today. Nothing exciting, really. I only have 2 lessons left, and then it's my test. So hopefully that goes okay, because I really want to drive. Like, I would very much like to drive. It would be very useful to me in so many ways right now. I very much wish I did it sooner, but I didn't, because I didn't think I would drive at all. And then I realized that, hey, driving is actually very helpful. So here we are. But anyways, does character terminate number? Here we go. So if does character terminate number, current, where are we? Where are we? Okay, yes. If it terminates, then what we do is we just break out of this loop. Nice and simple. Then we set the current to be consumed. Since we know it doesn't terminate, so we're going to consume the next character. We don't need to have it peaked anymore. We can just consume it. Then we need to switch on the type, because obviously different types, different logic. So we'll start with octal, since that's actually quite simple. If current is less than 0, or current is greater than 7, then type is equal to token Java token type dot number int literal, right? Because that means that we're no longer an octal number, it is just a normal integer, and then we can break that integer literal loop. Okay, then we have hexadecimal, which is somewhat not that bad actually. So if it's not hexadecimal, now I created a method for this, but to be honest, I don't think I need a method for this. Because it's quite simple, right? So I can just say this, basically. So character, that is current. What I'm going to do actually is I'm going to do character.to lowercase consume. How's it going? It's going pretty well, yes. Get rid of that. There you go. Yeah, things are coming along. It's going to take a while. This is going to take a while. This is just that kind of thing. That it just does take a while, unfortunately. Oh, I am actually going to want this. I see why I had it now, because we're going to want this for escape codes in strings. So, as much as it feels like it makes sense to do this, it doesn't. We're going to want a method to check. So let's have a... Where do I want to put this? Here, sure. Private static boolean is hexadecimal jar character. Return that. Easy but boring? Yeah, pretty much. That's pretty much exactly it. This isn't like anything hard. I mean, the only hard part is edge cases, right? You just have to make sure you're handling all the edge cases, but you know, if you are, then it's not really much of a problem. So yeah, anyways. Wait, I'm a little bit lost, actually. Ah, here we go. So if it's not hexadecimal current, then we want to append the number. So we want to say number.append current. And then we just want to continue until it's found what we want, right? So I'm going to copy this in and we'll just adapt it. Didn't I create this? Is does character terminate number? There you go. Which will be, let's not read the peak, so we'll do peak 1. And we'll say pos plus 1 is less than length. Current is equal consume, and then number.append currents. And that just continues until it's done. Wait, I think my code is wrong. I'm just looking at my code here, and I think it's actually wrong, right? Unless I'm missing something. So, if it's not a hexadecimal number, right, then it appends the current char, whilst it has another number, and it's not a terminating character, right, it appends them. But once this becomes false, it just returns an illegal token. Oh, no, that's correct. No, that is correct. Yes. Because it's hexadecimal. It's hexadecimal. So if I had 0x, you know, A or whatever, right, that's valid, right? If I then add something that's not valid, like L, right, this is no longer valid, but we don't want to start picking up things after this. Right, so we're just going to continue until we've found, you know, space, or we've found \n, right? So that's why it's doing that. I see. Okay. So yes, if this if statement is true ever, that means we've automatically hit the end of it, right? So in this case we want to, do we have an illegal thing, or error token, or unterminate? No, error token, I think. Enable completions, error token, valid hexadecimal literal, and I assume that automatically gives the yes. Well, actually, no, because this saying it's at that position, but it's not going to be at that position. It's going to be, if it's not hexadecimal, then we just return, right? Would be a better solution. I guess I want to append still, though, so that when it says it there, right, so number dot append, what's current? Current is already in consume. Oh, I see. Yeah, that's fine. That's fine. Okay. Then we have binary. So, binary, nice and simple, right? If it's not a 0 or it's not a 1, no, this is incorrect. Because it's 0b, so it's actually the same as this one. So if it's not a 0 or a 1, we once again want to return an error token in that case. The only one we don't do that with is the octal, because there's no like letter that defines it's an octal, right? So yeah, the binary is fine. And then this is after the switch. So after the switch, we just want to append the current number. And then after the while loop, if it's not a floating point literal, And then we do that. Is that correct? So if it terminates, current is equal consume, append the number. So if it's any of these, then it does those, else it just appends it. Yeah, that's correct. So it doesn't have a start offset. Int start offset pos line. There you go. That can go there, sure. That's fine. Okay. Is always true. Yeah, that's correct, actually. Right? Yeah, that's correct. So here, I do in fact want to just do this. Right? Now, if we are... Wait, this isn't correct, is it? This just breaks the integer literal loop, but that's not... Wait, I'm so confused. I'm trying to look at my code here, and it's not making sense. So, I do the switch on the type, right? But I do that here, so that's after we know it's a non-decimal, right? So we know that it's, you know, hexadecimal, binary, octal, or just integer. Right, so it does that. It goes through, blah, blah, blah. We switch on the type. If it's octal, then what it does here is it sets the type to integer, but then it's breaking the loop. And I don't understand why it's breaking the loop. Maybe this doesn't do what I thought it did. Maybe... I don't think this does what I thought it did. Let me go to token type. Is decimal. So if it's an octal or a hexadecimal or a binary. Ah. So it's saying it's not a decimal or an integer. Okay. Okay. No, and it's not an inch. Inch literal. That's why. So if this isn't that, and type does not equal that, so it's not floating point, and it's not... welcome back. I've once again forgotten how to... Wait, can I scroll up and find it? Suhaib. Welcome back. I think I said that right. If it's so yeah, this is this can't be correct. 1 second. I'm actually getting so confused by my own code right now. So if it's not that, So this is after the loop. Right, because this breaks the loop, right? I see. So we know it's not going to be this one. But we want to know that it's not this one. Because it's never set to this one. Which is why... Okay. Yeah, I got it. I got it. Don't worry, chat. I got it. Okay. Next we need to know if the character terminates. If it does, we just return that. Okay. Then we need to know if the current chart is an underscore, right? Because we need to handle, for example, 100 underscore 000. And then afterwards we're going to need to handle e's as well. Don't really want to do e's because e's are going to be a pain in the butt, but because I specifically didn't do e's in my in my language. But we'll come to that in a second. Its current is equal underscore. Then we want to check if it has a character next or not. So if pos is greater than or equal to length, then we want to return the, I think this one, no? Oh no, never mind, that's just for string literals. Invalid number literal. There you go. So then we want to say current is equal to consume. If it's not a digit and it's not a dot, then we want to return invalid number literal and then append it. Else we want to do number.append current. Okay. I think honestly, guys, I'm gonna end it here. This has just ended into writing a programming language stream rather than Railroad stream. I promise if I do Railroad streams in the future, they won't be quite this technical. Unless you guys like this kind of technical stuff. I don't know. Let me know, I guess. I think I'm probably going to end it here, though. Because we could go... I mean, you can see where we're at right now. We could go for hours longer. And maybe I will at some point. Maybe, because I do want to do a long stream at some point. I might even at some point do a 24-hour stream. Maybe. It is something I've been considering. Because I want to know if I can do it or not. I think I probably could. I could probably just about manage a 24-hour stream. So, I have been thinking about doing one of those at some point. In which case, stuff like this is perfect for that. That is perfect for a 24-hour stream because it's just, we're just typing away. There's nothing complex. It's not like super complex. And I mean, I probably messed something up here in this entire thing, because I'm writing a lot of code without testing it right now. So somewhere I'm sure I probably got a not the wrong way around, or, you know. But yeah, I think I'm pretty happy to end it here. We've been going for almost 4 hours. We don't need to go for, like, exactly 4 hours. That's not, like, some requirement I have. So yeah. I think I'm gonna end it here. I hope you guys enjoyed. And yeah, I will see you all probably with a video. I think there's a tutorial coming out soon. So yeah, I will see you guys then. You want me to finish the Fanta? Okay, I'll finish the Fanta. Okay, I finished the Fanta. Okay, so I will see you guys next time. Goodbye.